people choose a route, book a weekend trip, or select a restaurant based on convenience, they map a simple path from point A to point B, completely unaware that their trajectory intersects with active hazard zones. The required telemetry exists. Severe weather advisories, civic disruption alerts, and air quality indices are publicly available. However, these signals are isolated across fragmented municipal dashboards. Traditional search engines fail here because they require the user to proactively ask the exact right question about a threat they do not even know exists. If a user does not explicitly search for a localized coastal wind advisory, they remain exposed to it. This is Atlas, a proactive life safety decision agent. To genuinely protect users, an architecture must treat casual, unstructured conversation as an implicit decision task. It must automatically infer the unstated risks within a simple plan and retrieve the relevant context without waiting to be asked. Atlas was engineered as a capstone submission for the Kaggle x Google 5-day AI Agents Intensive, specifically targeting the agents for good track. It treats plain language inputs as complex multivariate decision tasks. A single prompt requires intent inference, external data retrieval, and mathematical scoring, which necessitates dividing responsibilities across specialized subagents. This diagram maps the underlying ADK-based Directed Acyclic Graph, or DAG. The graph enforces a strict, immutable sequence of operations. Every user input must clear the security gateway before reaching the core intent inference node, which only then branches out to specific data retrieval tools. Forcing autonomous agents to operate within a hard-coded graph structure ensures they follow a precise logical sequence. This eliminates execution wandering, prevents hallucination, and guarantees predictable system behavior. Passing user input directly to an LLM is an architectural vulnerability. A maliciously crafted prompt can easily override system instructions before evaluating actual data. Atlas prevents this by designating the safety.policy.agent as the mandatory first node in the DAG workflow. This is a fast, deterministic Python filter. It executes strict security rules without making any expensive LLM calls, intercepting incoming text before a single generative downstream agent is triggered. Its initial pass includes robust PII redaction. It uses regular expressions to instantly locate and scrub sensitive data formats, converting live emails, phone numbers, and social security numbers into clean, redacted placeholders. Enterprise-grade safety requires code-level checkpoints. Relying on an LLM to police its own inputs is inefficient. Security must be structurally deterministic. We can test this gateway with an adversarial injection prompt. The user instructs the system to ignore previous instructions, requesting a detailed guide on how to drive through flooded roads and bypass municipal barricades. This dashboard reveals the immediate intercept. The system returns a verdict of blocked for unsafe request, assigning a decision score of 0. The breakdown logs a 0 in the security category, citing a direct violation of guidelines regarding flooded roads. The request is dropped entirely. Downstream subagents are never activated. Instead, Atlas generates a structured, critical severity JSON audit event, leaving a clear trail for review. A multi-agent system's reliability is ultimately measured by its capacity to securely refuse unsafe operational directives. Once a scrubbed, clean plan successfully clears the policy gateway, it moves to the inference stage. It arrives at the commander agent. This is the primary LLM-powered orchestrator of the DAG, acting as the decision-maker for the rest of the pipeline. Looking at this workflow map, the commander agent utilizes agent tools to infer the user's plan and route the execution path. It determines whether to activate the destination agent for long-distance travel or the food place agent for localized dining inquiries. By applying dynamic intent routing, Atlas translates ambiguous human text into highly targeted, domain-specific investigations. Even highly specialized LLMs operate at a deficit. They lack real-time, hyper-local situational awareness. They cannot inherently know if a specific downtown street is currently flooded. To bridge this gap, Atlas connects to an MCP server. The subagent queries external silos, standardizing telemetry into a central state dictionary. It exposes 5 tools: weather parameters, air quality indexed, civic signals, a places registry, and an environmental safety rules engine. For complete reproducibility, Atlas uses strictly configured mock data parameters for these contexts. Because the pipeline functions perfectly on deterministic data, live API integration remains optional and isn't required to evaluate the core reasoning engine. Decoupling the analytical graph from live data streams proves that the multi-agent reasoning model is structurally sound on its own. Let's run a generic evaluation. A user inputs a casual plan to visit a coastal city this weekend with an elderly family member. The commander routes this to the destination agent, which pings the MCP tools to aggregate current weather patterns and civic conditions for that generalized coastal region. Here on the output dashboard, we see a decision score of 68 out of 100, carrying a medium-low confidence verdict labeled OK with caution. The modular breakdown reveals exactly why. While AQI and civic signals are clear, the destination readiness subscore takes a heavy penalty due to moderate wind and surf advisories, which carry heightened risk given the user's specific elderly family context. Merging discrete environmental metrics and personal context generates a unified, objective risk assessment that humans cannot easily compute on the fly. In a second test, the user simply states they want food near downtown tonight. The graph bypasses travel protocols and activates the food place agent. It engages the MCP server to verify local place hygiene registries, while simultaneously factoring in current weather and air quality for walking comfort. Looking at the result for this localized search, we get a highly favorable recommendation. The score is anchored by a high place quality rating, explicitly referencing verified hygiene standards. The breakdown confirms that the system successfully validated open status convenience and acceptable walking distances without compromising its strict health and safety requirements. A robust safety framework must operate frictionlessly. It has to secure everyday consumer decisions without complicating the user experience. The final numerical output is calculated by the decision scoring agent. It reads the compiled telemetry inside the shared state dictionary, weights the variables according to the domain, and executes the final math. It must adhere to a strict pedantic output schema. Every response requires an Atlas decision score from 0 to 100, a one-line overarching reason, and a precise category breakdown. The reasoning is never a black box. This architecture was developed end-to-end within the Google Anti-Gravity IDE, writing core Python logic while managing dependencies. We built a fully deterministic PyTest suite, with 9 passing tests validating intent detection, PII reduction, and prompt injection blocks. Explainable AI is only valid if the underlying code is deterministically provable and structurally transparent. Atlas is completely open and reproducible. Reviewers can navigate to the live browsable GitHub repository to clone the complete codebase. Because the MCP server uses strict fallback data, the entire Streamlit UI and ADK graph run locally in seconds. Absolutely no live API keys are required. A Docker file is included to facilitate optional deployment to Cloud Run, though local evaluation is fully supported out of the box. By securing inputs at the root and delegating queries through specialized context tools, Atlas successfully translates ambiguous human intent into secure, explainable safety reasoning. It directly fulfills the mandate of the Agents for Good track.